Let's talk about message queues, which is a very important part of a scalable backend architecture. And for that purpose, let's see an example. For example, we have a user who is coming into our website and registering in our application. So the user has sent a registration request to our server. And after that registration of the user is done successfully, let's say we want to send a welcome email to the user. So after the registration will be done from the server, it will send a task to the email worker that, okay, we have a user and we need to send a confirmation email or a welcome email to this new user that we have. Now, if that at that particular moment, if the email worker was up and running, then the task will be sent to the worker and the worker will successfully process the task and send a successful email to our user that we have. But let's say on that moment when the task got sent to the worker, on that moment the worker was down. Then what happens is the worker will never then send the email to the user, because on that moment when the worker came to know that it has a task of sending the email to the user, at that moment the worker was down. So it was never able to process it and never able to send the email to the user. So our purpose of sending the email to our user failed here. Then let's look at another scenario. Let's say we have an e-commerce application, and in this e-commerce application, we have a user who has placed a particular order. Now, once an order is placed, we need to look after various things in the backend, like we need to save the order, we need to send an email to the user about the order, we need to generate invoice, etc. Now, if we were to process all these requests one by one, like let's say we first saved the order and then we sent an email to the user and then we generated the invoice, and let's say only after all of these were done successfully, only then we let the user know that okay, all of these have successfully been executed and finally your order has been placed. Now, of course, to execute all of this, we will require some amount of time. And if we wait for all of these to get finished and then respond to the user, it will basically be a bad user experience because the user has to wait for a long period of time to get to know if the order has been successfully published. So it is basically a synchronous process. So to make these kind of processes synchronous and to keep and to address issues like this, we have something known as a message queue. So our message queue is basically like this queue structure right here. And onto this message queue, we can push various tasks that we have in our server. And then from the message queue, whenever the workers are available, we can push those tasks onto our workers, or the workers can keep on pulling tasks from our message queue. So this is like a queue structure from right here. And these like we can have various functions or various services which keep on pushing tasks to our queue. So these are basically tasks which are getting pushed onto our queue right here. And the things which are pushing these tasks to our queue are basically known as publishers, because these are responsible for publishing tasks onto our message queue. And then from the message queue, there are various types of workers which will pull these tasks, or we will send tasks to various workers. Workers are nothing but the different types of services which are responsible for handling a particular area. Let's say this is an email worker, so it will be responsible for sending email to the users. Let's say this is a notification service or worker, so it will be responsible for pushing or publishing a notification to the users. So these things right here, which are taking the tasks from message queue, are basically known as subscribers. So we have publishers which publish the tasks to message queue, and then we have subscribers which take the tasks from message queue. So these can pick tasks from message queue whenever tasks are available on the queue to be picked. So this is the typical pub sub architecture. So this is the typical pub sub architecture where we have publishers which keep on publishing or pushing tasks to our queue, and then we have subscribers which keep on pulling the tasks from the queue whenever a task is available. So let's say we created a particular task, like we have a particular task which needs to be addressed asynchronously. So this task from the publisher gets pushed into our queue. Then we have another task which needs to be performed. So this first task gets here and the second task which we need to perform gets pushed or enters our queue. Now, let's say after being pushed, it reaches to this point. Now, whenever the workers are available, let's say this was an email sending task. So this email worker will pull this task and basically send the email to the user. So this task will basically be pulled by this worker and this function will be performed. Now, if this email has been sent to the user successfully, then it will acknowledge the message queue that the service has been done successfully, and it will send basically an acknowledgement signal that it worked fine. But if by chance it failed, or the worker was down at that moment, or because of some reason the email did not get sent, then the worker will say that the email did not get sent and this task basically failed. So this can be processed later on by storing it in DL queues. Like we have a structure known as DL queue, which is similar to a queue structure, and here we store our failed tasks. So in this manner, we handle tasks in a queue. Now let's say this task comes on and it was something other task, like let's say a notification task. So if the notification worker is available, then this worker will pull this task and the notification task will be performed, or the user will get a notification, and based on the success or failure, it will return an acknowledgement to the message queue whether the task was a success or whether the task was a failure. So in this manner, tasks get pulled from the message queue, or the message queue may push the tasks to the different types of workers that we have. And that is how the pub sub mechanism for message queue basically works. Now, we had seen earlier that we were not able to send email because the worker failed, and this was the disadvantage of this architecture. And then we saw that if we had to wait for all these to process synchronously, then we had a long wait time. And for that purpose, we used message queues. So, how is message queue solving the purpose here? So, let's say we have this, we take this example of order here. So, once an order has been published by the user, then we have these three tasks which need to be performed, which is save the order, send an email, and generate the invoice, right? So let's say we have three different tasks which need to be performed after an order has been made. So an order has been made, and these are the three tasks that we need to perform. So all these tasks will be pushed onto our message queue one by one, and we will have these tasks lined up in our message queue. Meanwhile, our server can return to the user that your order has been published or the order has been posted successfully. Our server can say to the user that an order has been published successfully, and meanwhile, in the background, while it has been done, in the background, we can run these tasks. And on the basis of the conclusion of this task, we can then say that whether the order really got successful or whether the order failed. So let's say this was the save the order. This is the let's say this is the save order. Let's say this is send an email, and let's say this is the generate invoice task. So these are the three tasks that we have saved in our message queue for asynchronous working. Then when this comes on, this will get picked by, let's say, the server or the worker which deals on saving the orders. And then when the email one comes, this gets picked by the email worker. And then when the generation of invoice comes, then this gets picked up by the invoice generating worker. So in that manner, we processed all these tasks which we had asynchronously without letting the user completely wait for all of these to get completed and then send the response. We first acknowledged the user that, okay, your order has been published. And meanwhile, after saying that in the background, without wasting the time of the user, we have basically processed these tasks asynchronously. So that purpose got fulfilled. Now, talking about the email sending system, let's say we have three emails to send to different users. So we have these, let's say these are three tasks of sending three emails to three different users. Now, when the email worker was up and running, it said that, okay, I'm functional. So give me this task of sending the email. So this email sending task got sent, and then the worker was running. Therefore, it successfully sent the email. Then the second email got picked, and let's say at that moment, the worker picked the email process or the email sending task. But during that moment, due to some error, the worker got down, or the worker basically got temporarily down. Now that the worker has gone down, it cannot send the email successfully. So this email sending task became a failure. So this email did not get sent. Now that this email did not get sent, an it will send an acknowledgement to the message queue that this particular email task that I had was not able to get processed successfully, and this email basically got failed. Since this email task sending task got failed, we can separate it out and store it in a structure called DLQ, which is similar to a queue, but it stores failed tasks. So once this worker failed, we took out the task. We marked this that okay, this service failed or this particular task failed, and then we took the failed task and stored it separately in a DL queue. And later on, this task can be again pushed onto the message queue and then again can be processed once the worker is up and running. So let's say now the worker again became up. So again, now the worker started working or the email worker is fine. So again, the next email task got correctly placed and the email got correctly sent. And then again, for the failed task that we had in DLQ got pushed to the message queue. And now that the worker is running, it will now take the task and then successfully send the email. So basically, earlier we were never able to send the email to the user, but in this case, we stored the failed task, and then with the help of message queue again, we were able to successfully publish or successfully send the email to the user. In this manner, message queue gives us various different kinds of use cases in our architecture to make it to make our architecture very efficient.